Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So here we will discuss about the comparison of reactivity of the halogens. Basically, the halogens, these are the group 7 elements, or if we talk about from this one to here, then they are making up the group 17 elements, but on a whole, we call them the group 7A elements. These are from the group A elements, and they include the fluorine, chlorine, bromine, iodine, and astatine, where the fluorine its atomic number we have 9. So these are collectively called as the halogens. Basically, all these fluorine, chlorine, bromine, and iodine they exist in the form of diatomic molecules or in the combined state, and both the fluorine and chlorine are in the form of gas or gaseous form. The bromine it is present in the liquid state, and here we have the iodine and the astatine, in which the iodine is the element which is existing in the form of solid as solid iodine, and the last one which is called as astatine. Due to some physical properties it is not studied as a very radioactive element, so this is rare. Now we will talk about their reactivity, that how do they react, which one is more reactive and which one is less reactive, we will study about there. Basically, the halogens just give the type of reactions in which they can react with chemically as the hydrogen. It can react with the water, the hydrogen gas as its formula is H2. It can react with the water as the formula is H2O, and it can react with the methane. Its formula we has CH4. So the halogens have a lot of reactions. All that just depend that what type of halogens we are going to be used, because they are four: fluorine, chlorine, bromine, and iodine. All these four just required one electron in their valence shell to complete their octet and to get the stability. So all that depend to which substance they are going to react and to form a stable compound. Now the first one we have its reaction with the water or the reaction with the hydrogen. First one is fluorine. It can react in the dark and cold state with the hydrogen and producing a type of acid which is called as hydrofluoric acid. This is called as the hydrofluoric acid. And then the second we have the second halogen which is chlorine. It do react with the hydrogen and produces the acid. This acid is as HCl, and the name of this acid is called as hydrochloric acid, and that reaction just happened in the presence of sunlight. Then the third one halogen which is the bromine, it reacts with the hydrogen. It only reacts upon heating and produces HBr, hydrobromide bromic acid. The fourth one is hydrogen. It reacts with the iodine upon heating and in the presence of catalyst and produces hydrogen iodide. So in the reaction with the hydrogen, we just have noticed that the reaction of the fluorine is high as compared to the chlorine. Chlorine is then less reactive as compared to the fluorine, but more reactive as compared to the bromine because it requires sunlight. Bromine requires heating and the iodine requires heating plus catalyst. So bromine is more reactive as compared to the iodine, and among all the iodine is least reactive and fluorine is the more reactive halogen among all. So this is a simple its reaction with the hydrogen. After this we have its reaction with the water. Now how do it reacts with the water? The fluorine when it do reacts with the water in dark and cold state, it produces HF, hydrofluoric acid, and oxygen gas. Chlorine, on reacting with the water, produces HCl, hydrochloric acid, in the presence of sunlight, and HOCl, hypohalous acid. Bromine, it reacts upon heating with the water as HBr, hydrogen bromide, and hydro hypobromic acid. Then the last one is iodine. On reacting with water, it gives no type of the products. So the reaction of the fluorine is high. It is more reactive as compared to the chlorine. Then chlorine is more reactive as compared to the bromine. And at the end, the least reactive is the iodine. So when we move from top to bottom in the group, we just see that among the halogens or in the group 7A, the fluorine is having high reactivity. Fluorine is more reactive among all the halogens. So this is the simple example of the reactivity of the halogens with the water. And after this, we have its reaction with the methane gas. Like here we have methane, CH4. When it do reacts with the chlorine, it produces the carbon and the hydrochloric acid. So this is the reaction with simple HCl or hydrochloric acid with the methane. But when we talk about the other halogens like fluorine, bromine, and the iodine, among which the fluorine, as it reacts with the methane violently, with the methane in the dark, and on the other hand, the chlorine, it reacts with the methane and produces the carbon. It just only happened in the presence of sunlight, and at the end, we have its reaction with the bromine. Its reaction with it is very slow, and when it is reacting with the chlorine as methane, it produces a lot of series of the compounds, and these compounds can be like CH3Cl. After that it produces CH2Cl2, then CHCl3, and at the end it produces CCl4, which is called as the carbon tetrachloride. And this is the simple reaction of methane with the halogen. So this was the simple reaction or reactivity of the halogens we have. I hope you guys understand. And if you have any queries, you may ask me about that in the comment section, and I will get back to you guys soon. The next topic that we will discuss, it is the oxidizing properties of the halogens in detail. For that time, you guys keep learning and have a good day.